All right, so Jessica rolled a die 10 times below are her results. So this is Jessica's experiment. If you are doing an experimental probability, you're going to use that data. What are you going to use if you're doing a theoretical probability? What is it? No, I'm asking you what you said. I didn't hear you. You said the faces?
I know it's not too much, it's like the wheel, it's just 1, 2.
So what numbers?
Yeah, just
What numbers on the dice? Like what numbers would I
3,
use?
4, 5.
Yeah. So like the actual dice just has 6 numbers, right? So like when I'm thinking of experimental, I'm going to use the data, and when I'm thinking theoretical, I'm going to use an actual dice, which has 6 numbers on it. So I'm going to use these numbers for theoretical, these numbers for experimental. Experimental, the data, the device itself was a dice, so we're going to use 1 through 6. So the first question says, what's the theoretical probability of rolling an even number? So I'm looking at this. I'm looking at an actual dice. How many even numbers are there? 1, 2, 3. Right? 3 out of a total of 6 numbers, or 1/2. What's the experimental probability of rolling an even number? 1, 2, 3, 4, 5, 6. How many numbers were there? 10. And so if we reduce that, 3/5. See, they're not the same number. They can be, they just aren't in this specific instance. What's the theoretical probability of rolling a 2? So I'm going to look at this data. How many 2s? 1, right? Sometimes that's tricky because the kid wants to put 2 out of 6 because like the number's 2, right? But it's how many number 2s are there. 1 number 2 out of 6 total numbers. What's the experimental probability of rolling a 2? We've got 2 2s out of 10, and that reduces to 1/5. So experimental probability, you're using the data. Theoretical probability, you're not using the data. Use the experimental probability in number 4. So I'm going to use my 1/5. You could also use the 2/10, right? The answer to number 4 is 1/5 or 2/10. To determine how many 2s Jessica would predict after 75 rolls. So I'm going to set up a proportion where 75 is on the bottom. And how do we solve a proportion? Cross multiply. So you're going to make this x. All right. So 1 times 75 is equal to x times 5. And we divide by 5. What do we get? 15? And I don't have to round that because it's a whole number. So I would expect to get 15 out of 75, which is 1/5. If it said use the theoretical probability, it would have been a 1/6, and I would have done something different. Experimental versus theoretical, okay? For now, we're going to ignore this idea of complement probability from yesterday, and we'll get back to it when we can. It's pretty simple, it's pretty short, so we'll get to it throughout this unit when we get a chance. But for today's sake, we're going to keep moving on with this stuff, with the new unit, and we're going to work on relative frequencies. So basically, the only difference is we're going to see data from a table, so it's going to be an experimental probability. But instead of seeing it listed out in a row, you're going to see it in a table. We're still doing experimental probabilities. We're still doing it the same way. You're going to see it in a table. All right, it's pretty simple. So the concepts of this are on page 3 of your toolkit. You'll see this table. It says the results of the survey of students' music preferences are organized in this frequency table. Okay, so frequency means like how often something happens. So when it says type of music preferred, rock, and then frequency of 10, that means that 10 students selected that to be their favorite type of music. When it says hip hop, frequency 7, that means 7 students selected that to be their favorite. So it says how many people were surveyed. Well, what do you think we do for that? Add them together. Let's do it. So someone has a calculator out. I don't have my calculator app open here. Let's do 10 plus 7 plus 8 plus 5 plus 6 plus 4.
40.
Thank you. All right. Add the numbers together. We get 40. This is coming from 10 plus 7 plus 8 plus 5 plus 6 plus 4. You're going to see a question that says, what is the relative frequency? Really, I'm just saying, what's the probability, right? Relative frequency is probability. So what is the probability of having a preference for rock music? So I'm going to take the number of people who like rock music out of the total number of people, which is what I just figured out. So the number of people who like rock music is 10. If I go to rock, and I look next to it, and then the total number of people is 40. And then 10 divided by 40, if I simplify that, is 1/4. So we just want to simplify when we can. So new word here would be relative frequency, but it really is an old word, experimental probability. The difference between an experimental probability and a relative frequency is a relative frequency is in a table. And an experimental probability is not necessarily. Same idea though, right? So it says, what is the relative frequency, which is really the experimental probability, of a preference of classical music? So I go to classical. There are 5 people who picked classical out of the total number of people, which is 40. And then if I simplify that fraction, that's 1/8. So we're just reading the table. Questions there? The next example is a little more confusing, not because of the table, but like the actual experiment itself is kind of confusing. So it says, a student conducts a probability experiment by tossing 3 coins one after another. For example, HHH means that she tossed a heads 3 times in a row on 5 different instances. So she's going to flip, 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 record. So this 5 means she flipped, 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 and got 3 heads in a row, but she did that 5 different times. All right, this is, she got a heads, and then after the heads, then she got a tails, right? Heads first, heads second, then tails, 7 different times. Heads, tails, tails. She got a heads, then a tails on 9 different occasions. So it says, how many experiments were done? How do you think I could figure that out? Adam, right? So let's do 5 plus 7 plus 9 plus 6 plus 2 plus 9 plus 10 plus 2. 50? Thank you. Okay, so if 50 experiments were done, how many times did she toss the coin? Times 3. 3 flips is 1 tally, right? So it's flip, 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 1 experiment. Flip, 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 2 experiments. So we have to take the total number of experiments and multiply it by her 3 flips each time. So really she flipped the coin 150 times. All right. So the question says, using the results, what is the probability that exactly 2 heads will occur? So here's what you're going to do. You're going to find anywhere where there's exactly 2 H's, okay? So this is 3 H's. That's not exactly 2. This is 1, 2 H's. So I'm going to use this 7 times. This is only 1 H. This is 2 H's. This is 2 H's. This is only 1 H. This is 0 H's and 1 H. So exactly 2 H's happen for those experiments. So 7 plus 6 plus 2. You get 15? Out of the total number of experiments, remember, When we added these numbers up, if we're using these numbers, when we added these numbers up, we got 50. If I divide each of those by, if I were to do 15 divided by 50, math, enter, enter, 3/10. I just think that table's kind of confusing to read with the H's and T's. All right, last one. It says a student conducts a probability experiment by spinning a 4 equal section spinner. How many times was the spinner spun? So here's what we're going to do. To get the total, we're going to add 29 plus 32 plus 21 plus 18. What is it? Thank you. The spinner was spun 100 times. What is the experimental probability? So use the data. What is the relative frequency? Use the data of spinning a 4. So I go to this 4 and I see how many times the 4 was spun, which is 18. So we're going to do 18 out of 100. Or 9 out of 50 if you reduce that fraction. What is the relative frequency, experimental probability of not spinning a 2? Okay, this was from yesterday. Okay, complement probability. You can find, just kind of like off to the side here, what's the probability of spinning a 2? All right, so 32 out of 100. So the probability of not getting a 2 would be all the other stuff. So to get the other stuff, you take the total number of numbers, which is 100, and you subtract the 2's, which is 32. So I'm doing 100 minus 32. So we have 68. And then we put that over the total. So 32 numbers are 2. So 68 numbers are not 2. So one way to do it is just to subtract from the total the stuff that is a 2. Another way to do it would just be to add the numbers that don't have 2's. 29 plus 21 plus 18. That would be an alternative. Okay, so we would get the same number that way. So this is 68 out of 100. What does that reduce to? Thank you. So that's the idea of complement probability when you see that word not. All right, the last one says, what's the theoretical probability of spinning a 4? Very good. How'd you get it? So there's a 4 equal section spinner. Theoretical means I don't want to look at the data, I want to look at the spinner. If that's the spinner, how many numbers are the number 4? 1 out of 4. So the theoretical probability is 1/4. So this question kind of has everything from this unit so far, including that complement that we didn't do. All right, I think we've got some time. All right, so I'm going to have you try some practice. As you're doing the practice, I'm going to start to just write the answers on the board because we have, 9 minutes? I just want to make sure that you're kind of just checking as you go. So this is workbook page 4 and 5. If the numbers at the bottom of your book are confusing you, I have screenshots of the problems I want you to do, okay? You're using tables, so you're going to have to total up the frequencies, and that'll be your denominator number, and then look at what you're trying to find. I'm actually going to have you skip the second one. So really just working with the tables. So you're doing 1, 3, and 4. If you're not sure that you're on the right page, look at the pictures on the board. They match the problems I'm looking for you to do. looks like some of you still haven't finished that second page, 3 and 4, so I'm gonna give you a minute or two more. What's the relative frequency of blood type A? I heard 25 somewhere. All right, so there's 25, and then the total is 63. All right, so that answer should be 25 out of 63. What's the theoretical probability of blood type A? How many blood types are there?
1 out of 4.
Yeah, hypothetically it would be 1 out of 4. I don't know if that's actually true. I think it's not true. I think isn't O like really hard to get? Not a lot of people have one. So theoretically 1 out of 4. All right. Skip number 2. Let's look at this one. It says, what's the probability that a randomly chosen preschooler picked popcorn as the favorite snack? So I went over here and I totaled it for you, right? Like, so there was 8 people for bananas, 5, 4, and 6. That's a total of 23 kids. So of those 23 kids, 6 of them picked popcorn, and then that doesn't reduce, so that one's just 6 out of 23. Theoretical probability, 1 out of 4, right? But this one's saying use the data, so we're going to say 6 out of 23. And then the last one says, what is the probability of not bananas? So this is kind of a new concept since we missed the ed puzzle yesterday. What I can do is figure out how many do like bananas. How many like bananas? 8, thank you. So 8 out of 23. So all of the other kids didn't pick bananas. So what I could do to get not bananas is I could take the 23 kids and subtract the 8 that picked it. And put that number over 23. So what's that? 15? So 15 out of 23. Another way to do it would just be to add the trail mix plus the celery and cheese plus the popcorn. Just don't put the bananas in that group. You're going to get 15 that way too. That's the idea of complement probability. That's what this ed puzzle yesterday said. All right? So no homework for tonight. Don't worry about the ed puzzle. Don't worry about the Canvas. When you come in tomorrow, it'll be a normal day. Now, you're going to go to block 2 next. Okay, so we're in order for now. Then it's going to switch up a bit. So you're going to block 2 next.